Hello everyone! Today we are going to explore a very important concept in electrostatics, conductors and insulators. This concept helps us understand why electric charges behave differently in different materials. Let's start with a simple question. Have you ever touched a metal object and felt a shock? Or wondered why electrical wires are covered with plastic? The answer lies in the way different materials interact with electric charges. So what exactly is a conductor? A conductor is a material that allows electric charge to flow through it easily. In other words, if you give a conductor some charge, the charge can move freely throughout the material. This is mainly because of the presence of free electrons, also called mobile charge carriers, which are loosely bound to atoms in these materials. Common examples of conductors include metals like copper, aluminum, silver, and even the human body. Yes, your body is also a conductor of electricity. That's why we feel a shock when we touch a charged object, because the charge flows through us to the ground. In conductors, charges don't stay localized at one point. Instead, they spread out quickly across the surface. This behavior is very useful in practical applications. For example, in making electrical wires and circuits where we want current to flow efficiently. Now let's talk about the opposite, insulators. An insulator is a material that does not allow electric charge to move freely. In these materials, electrons are tightly bound to the atoms and cannot move easily. So when you charge an insulator, the charge tends to stay where you put it. It doesn't spread. Examples of insulators include materials like plastic, rubber, glass, wood, and dry air. These are the materials we use when we want to prevent the flow of electricity. That's why electrical wires are coated with plastic. The wire inside conducts electricity, and the outer plastic layer keeps it from leaking out or giving shocks. Let's take a very common example, a plastic comb. When you rub it on your hair and bring it near small bits of paper, the paper gets attracted. Why? Because the plastic comb is an insulator. The charge that builds up on it stays on the surface. It doesn't flow away, and that static charge pulls the paper bits. So now, you might be wondering, what's the main difference between conductors and insulators at the microscopic level? The answer lies in the atomic structure. In conductors, the outer electrons of atoms are loosely attached. They can easily leave their parent atoms and move through the material. We often describe this as a sea of free electrons, and this is what allows charge and electric current to flow. In insulators, on the other hand, the electrons are tightly bound. They're not free to move. That's why even if you apply a charge or an electric field, the electrons don't travel and no current flows. There's also a third category of materials that you'll encounter, called semiconductors. These are materials that behave like insulators under some conditions, but can also conduct electricity under other conditions, like when they're heated or exposed to light. Examples include silicon and germanium. These are the backbone of modern electronics, used in solar cells, diodes, and computer chips. To summarize everything we have discussed, conductors allow electric charge to flow freely. They have free electrons. Examples: copper, aluminum, human body. Insulators do not allow charge to flow. Electrons are tightly bound. Examples: rubber, plastic, wood. In conductors, charge spreads over the surface. In insulators, it stays where it was placed. Semiconductors are in between. They conduct in specific situations. Understanding this difference is crucial, not only in physics, but also in real life. Whether it's designing electrical circuits, protecting ourselves from shocks, or building complex electronic systems, this simple distinction between conductors and insulators makes a huge difference.